Imagine you're a consultant. It's like early Monday morning, you haven't even finished your first cup of coffee yet, and you are prepping for this massive client meeting.
Oh, yeah, the classic high-stress scenario where
Yeah.
you're desperately looking for any kind of shortcut.
Right. And you've just been handed this dense 90-page client proposal,
Oh.
and your boss gives you one simple-sounding question to answer. What are the main contractual risks?
Which is never as simple as it sounds in a 90-page document.
Exactly. So naturally, you take this behemoth of a PDF, you drag and drop it into one of those popular AI chat assistants, and you just ask it for the main risks.
Like anyone would do nowadays, yeah.
Yeah. And within seconds, I mean, literally seconds, and the screen just fills up with this beautifully formatted, highly professional list of bullet points. You're feeling like a genius.
Until you look a little closer.
Right. You get to bullet point number 3, and it says, the supplier retains the right to raise prices with just 7 days' notice.
Oh, wow. Yeah, that is a terrifying clause for any client to agree to.
Total panic mode. Yeah. So you hit Control F, you start searching the document for 7 days, you search for raise prices, notice, whatever.
Trying to find where it actually says that.
But you can't find it. It's not there.
Yeah.
You read the section the AI supposedly pulled it from, and there's nothing. That alarming clause literally does not exist anywhere in those 90 pages.
Right.
The AI completely made it up.
It just fully fabricated a legal risk.
Completely. Welcome to No Hype AI, the podcast that explains modern AI without unnecessary complexity or vendor hype. This episode explores just one of the ideas from the AI Builders Foundation, a practical, no-hype book about understanding AI and learning to build with it. Follow the link in the description to discover the complete book.
It's such a perfect example to start with, though.
It really is. Today's deep dive is entirely dedicated to unpacking exactly what went wrong for our panicked consultant there. We're going to figure out why these language models can sound so incredibly confident while being completely factually wrong.
Yeah, and we really want to help you shift your perspective today. It's all about breaking that habit of looking at AI as this, magical, all-knowing brain.
Right.
We need to start seeing it for what it actually is, which is a system of very distinct mechanical parts.
Exactly. So our mission for this deep dive is basically to give you the tools to distinguish between fluent wording and verified fact. Because, as we just saw, fluency definitely does not mean factual.
Not at all.
Okay, let's unpack this. Why did the consultant get tricked so easily? I mean, when you look at that chat interface, the AI's response looks like real evidence of careful, thoughtful reading.
It does.
It uses all the right legal jargon, the right tone.
Yeah, it creates this perfect illusion of competence. And that's honestly the core value, but also the fundamental danger of modern AI.
It's a double-edged sword.
It really is. I mean, these models process human language and produce useful drafts at speeds that are genuinely remarkable. But as humans, we constantly conflate confidence with accuracy.
Right. If someone sounds like they know what they're talking about, we just believe them.
Exactly. The problem in that Monday morning scenario wasn't that the AI was being stupid, per se. The problem was that it generated a response without actually grounding its claim in the uploaded document. It performed what we call a plausible generation.
Plausible generation.
Mm-hmm.
Okay, I like to think of a language model like an incredibly confident improv comedian.
Oh, that's a great way to look at it.
Right. Like, if you've ever been to an improv show, the actors will ask the audience for suggestions. They're like, give me a location and an occupation.
And someone yells out, a dentist on a submarine.
Exactly.
Yeah.
And the very second you yell that out, they instantly start acting it out. They never hesitate for a second. They sound totally convincing in their roles.
They commit to the bit completely.
Totally.
Yeah.
But they are making it all up on the spot based on your prompt.
Mm.
They aren't lying to you, really. They just are optimizing for truth.
Right.
They are optimizing for a plausible, entertaining continuation of the scene.
Yeah, that analogy highlights the mechanics perfectly. Because to understand why it generates rather than retrieves, we kind of have to look under the hood for a second.
Let's do it.
When you ask a language model a question, it's not reaching into some hidden, perfectly organized filing cabinet of verified facts.
Right. It's not looking up the answer.
No, it's not retrieving an answer at all, not in the way a traditional database does. Instead, it's doing math. It is computing an output based on vast statistical patterns that it learned during its training.
So it's just predicting.
Exactly. It's mathematically calculating what words are most likely to logically follow the words you just gave it in your prompt.
Wait, so when it generated that totally fake 7-day notice clause for our consultant, it was really just predicting the next mathematical token that happened to look like a typical contract risk.
Yeah, that's exactly what happened.
So it's just a next word prediction engine, not a truth engine.
Right. Its statistical patterns basically said, legal contracts often contain clauses about sudden price increases. And it just wove that into the answer, regardless of whether it was actually in that specific 90-page PDF.
Wow, it just produced text that was structurally consistent.
Yeah, fluent. But fluent or consistent wording alone does not establish that a result is correct. It just establishes that it sounds like a normal human sentence.
Right, which is wild to think
It
about.
is. And it's a huge paradigm shift from how we are used to interacting with software. Because think about traditional rule-based software for a minute, like a program that calculates sales tax at a grocery store.
Okay.
The rules there are totally explicit. You have a location, you have a product category, and a price.
Right. Very clear data points.
Yeah, and the developer writes exact logic. They write, if the location is X and the product is Y, multiply the price by Z. It's entirely deterministic. You put the same numbers in, you will get the exact same output every single time.
But you can't really write a rule book like that for everything, right?
Not at all.
Like, take a spam filter for your email inbox. If you tried to use that old rule-based approach, you'd write a rule that says, like, block any email with the word prize.
And then your legitimate marketing newsletter gets blocked.
Exactly. So then you go, okay, well, block emails with too many exclamation points instead.
But then your very enthusiastic aunt gets blocked.
Poor Aunt Susan. Right. Senders are constantly changing their tactics, so the boundary between what is spam and what is not spam is just way too messy for a hard-coded rule book.
Yeah, and this is where learned models step in, and it's so vital to grasp this difference. Instead of giving the computer a rigid rule book, you give it examples.
Lots of examples.
Thousands or even millions of them. Some are labeled spam and some are labeled not spam. And during its training phase, the system adjusts its internal mathematics to capture the statistical patterns that actually separate those two groups.
So it's finding the patterns itself.
Exactly. When a new email arrives, it doesn't go check a rulebook. It estimates which group this new message statistically resembles. And that, right there, is the unifying thread of all modern AI.
Prediction.
Prediction. It's all about prediction.
Whether it's like predicting if a machine part on an assembly line is going to fail, or predicting what song you want to hear next on your playlist, or predicting the next word in a sentence.
Yeah, exactly.
And when we talk about language, we call those small units of text tokens, right?
Right.
Like a token might be a whole word,
Yeah.
or sometimes it's just a part of a word.
Correct, yeah. It could be a syllable or a prefix. When a language model generates a sentence, it is repeatedly predicting a suitable next token. It's building the output. It's one small piece at a time.
Kind of like laying down tracks right in front of a moving train.
That's a good way to picture it. It looks at the prompt you gave it, calculates the most probable next token, adds that to the sequence, and then calculates the very next one based on that new sequence.
Yeah.
And it does this blindingly fast.
Which is what creates that, continuous stream of thought we see typing out on the screen.
Yes.
That broad exposure to tokens is honestly what fascinates me the most, because learning to predict the next word across billions of pages of internet text, it exposes the model to an incredible amount of structure.
Oh, absolutely.
Like, to successfully predict what comes next in a biology textbook, the model implicitly has to learn patterns of biological facts. To predict what comes next in a Shakespeare play, it has to learn patterns of style and grammar.
Right, and to predict the end of a logic puzzle, it actually has to learn patterns of reasoning.
It's wild.
It really is. It basically builds a highly compressed mathematical representation of human language and logic. But, this brings us to a really critical misunderstanding about how that model interacts with the documents we give it.
Oh, this is the context window thing, right?
Yeah. When you upload a document, you are putting it into the model's context window, which is essentially just its temporary workspace for that specific conversation.
And this is exactly where people trip up. When our consultant uploaded that 90-page document into the chat interface, they probably felt like they were teaching the AI or like giving it a permanent memory.
Yes, people always think that.
But they were really just giving it a very, very long, temporary starting prompt for its next token prediction, right?
What's fascinating here is how quickly we anthropomorphize that context window into human memory. We just assume it remembers.
Because it talks like a person.
Exactly. But a language model has no persistent memory of your conversation once you close that window. None. Unless the overarching system is specifically designed to save your text and refeed it back into the context window next time you log in.
So it's basically amnesiac.
Completely. It just recalculates the math from scratch every single time. And this reliance on probabilistic prediction provides incredible flexibility.
Right, like being able to spot totally new, never-before-seen patterns of suspicious bank behavior.
Yes, it's amazing for that. But it is terrible for exactness. It's terrible for situations where known rules and explicit logic are required.
Here's where it gets really interesting, I think. Because a model is just a token prediction engine, you can't just slap a chat interface on it, hand it to a consultant, and call it a reliable tool.
You really can't.
People constantly blame the AI when it hallucinates or makes a mistake, like with our consultant's contract. Okay, the AI messed up, but they were blurring the components together.
That's the core issue.
In that scenario, the model actually did exactly what it was designed to do. It generated plausible-sounding text based on learned patterns. It didn't fail. It was the system that failed. Or, well, I guess the lack of a proper system.
Yeah, if we connect this to the bigger picture, you have to build a system around the model to make it reliable. We really need to define 3 distinct layers that people constantly conflate.
Let's lay them out.
Okay, so you have the model, the application, and the system.
No.
The model is just that learned computational component we've been talking about. It maps an input to an output, text goes in, predicted text comes out.
Simple enough.
Then you have the application. This is the visible interface. It's the chat window, the buttons you click, the app you download on your phone. It's just how you, the human, interact with the model.
Which leads the system.
Right. And that is the much larger arrangement of parts required to produce a dependable outcome. It includes the learned model, sure, but it also includes ordinary traditional code, hard-coded safety rules, external databases, search functions, user permissions, all of that.
So the developer who built that chat application for our consultant, they basically just wired the chat box directly to the raw model.
Which is a guaranteed recipe for disaster in a high-stakes environment. A raw model will always, always prioritize fluency over factual accuracy if you leave it unchecked.
So if you were the engineer, how would you actually fix the consultant's problem? Like using a true system architecture?
Well, first off, I wouldn't let the language model try to read all 90 pages at once and just guess the answer.
Too much room for error.
Way too much. First, I would build a data retrieval component. I'd use traditional rule-based software to divide that 90-page proposal into searchable chunks, and I'd store them in a standard database.
Okay, making it manageable.
Exactly. Then, when the consultant asks about, contractual risks regarding pricing, the system wouldn't go to the model first. It would first search that database and pull only the exact paragraphs mentioning price changes.
Oh, I see. So you're narrowing its focus so it doesn't have to guess.
Yes, precisely. Then I would feed only those specific relevant passages into the language model's context window, along with a very strict hard-coded prompt. Something like, summarize the risks found only in the provided text. Do not use outside knowledge.
That grounds the generation in actual physical evidence from the text.
Yes, but you wouldn't stop there, right?
I would hope not.
I would require the system to output source citations, page numbers and exact quotes beside every single claim it generates.
So you can check its work.
Exactly. And finally, the most important system component of all, I would force human review.
Mandatory verification.
Yes. The interface would require the consultant to physically click the citation and verify the original text before they could even copy-paste the answer into their final report.
Wow. Okay. That is the night and day difference from the first scenario. You took a raw, hallucination-prone text generator, and you just wrapped it in retrieval, strict rules, and human oversight.
Because a capable model does not guarantee a capable system.
I love that. A capable model does not guarantee a capable system.
And honestly, this is a trap that even big tech companies fall into. They think an agent is just a language model hooked up to the internet.
Right, just let it browse the web and do things.
But taking action requires vastly more engineering than simple text generation. If an AI agent is going to autonomously, say, book a flight for you,
it needs tools to interact with airline APIs.
Yes. And it needs what developers call state management, which is the ability to remember where it is in a multi-step process. Did I book the outbound flight yet? Did I pay? And it needs hard-coded rules for what to do if the credit card is declined. A voice assistant on your phone isn't just a speech model. It's a whole ecosystem of components working in tandem.
So if building a robust system is this complex, How do I actually know if my problem needs an AI system at all? Or if I just need a standard database? It kind of feels like we're trying to force this shiny new technology into every single workflow these days.
We definitely are, and it raises a really important question about mapping capabilities to actual problems. The landscape of modern AI can generally be broken down into four broad roles.
Okay, let's go through them.
If you understand these four, you can evaluate almost any AI pitch that comes across your desk.
Good to know.
The first role is perception. This is when AI takes messy, unstructured inputs from the real world and turns them into structured data.
Like transcribing audio.
Exactly, turning noisy spoken audio into a clean text transcript, or looking at a fuzzy medical scan and highlighting anomalies.
Right, because the real world just doesn't fit neatly into an Excel spreadsheet, so these perception models do the translating for us.
Spot on.
And I'm guessing the second role builds on that statistical engine we talked about earlier, prediction.
That's the one. Prediction is all about estimating a category, a likelihood, or a preference.
Like, is this credit card swipe fraudulent?
Yes. Or, what movie will this user want to watch next on streaming? These models output probabilities to help humans make better decisions.
Okay, so perception, prediction, and the third one has to be generation, right? And since that's what's stealing all the headlines right now.
Yeah. Producing new drafts, writing code, creating images from a text prompt. Generation is highly valuable when quick iteration matters, and this is crucial when a human is going to review the result before it goes live.
Right, like drafting an email that you tweak before sending.
Exactly. But the fourth role is where things get significantly more complicated, and that's coordination.
Coordination.
This is the massive promise behind autonomous AI agents. The idea is that the AI interprets a high-level goal, chooses which external tools to use, and moves through a multi-step workflow entirely on its own.
But isn't that where things get super dangerous?
No.
I mean, we just established that these models are prone to hallucination.
They absolutely are.
So if a coordination model is taking external actions on its own, like sending emails to clients or moving money around, a tiny hallucination early in the process could snowball into a massive disaster.
You've hit on the exact vulnerability. Coordination definitely reduces repetitive human effort, but the cost of an error skyrockets when a system is allowed to take external actions without oversight.
Right.
In a coordination system, an error doesn't just mean a typo in a draft. It means a cascade of wrong actions out there in the real world.
Yikes. So what does this all mean for you listening right now? I think it means that the next time someone at work pitches you an AI solution, you shouldn't just ask, is it AI?
No, that's the wrong question.
You should be asking, what specific capability, perception, prediction, generation, or coordination is the model actually providing? And more importantly, what system is built around it to check the results?
Absolutely. And you also need to know when to walk away entirely.
Just say no to AI.
Yeah. Ordinary, traditional software is usually better when the rules are known and stable, when the output must be perfectly exact every single time, or when a simple database lookup answers the question perfectly well.
Right. If you need to know exactly how much money is in a bank account, you don't want a language model predicting what your balance probably looks like.
No one wants a probabilistic bank balance. You want a deterministic database query.
For sure. One of the best mental models for making this decision is looking at a 5-point evaluation checklist before adopting any AI tool. The points are task, signal, risk, verification, and value.
It's a great checklist.
Let's break these down because I feel like they force you to treat AI like a practical engineering component, not magic. Starting with task. What exact job is being automated?
Yeah, a lot of projects fail right out of the gate because the task is just way too vague. People say, we're going to use AI to improve customer service.
That means nothing.
Right. You need a highly specific task, like drafting initial replies to refund requests based on the return policy.
Much better. Okay, second is signal. Is this problem governed by stable rules or by messy patterns?
This goes back to our sales tax versus spam filter analogy. If you are calculating employee payroll, the signal is stable and rule-based. Just use traditional software.
Don't use AI for payroll.
Please don't. But if you are doing sentiment analysis on thousands of customer reviews to see if they are mostly angry or happy, the signal is messy. That's where a probabilistic model shines.
Okay, third is risk. And I think this is honestly the most misunderstood one. What actually happens to the user or the business when the output is wrong.
The key thing to understand about risk with AI is the concept of a silent failure.
Silent failure, okay.
When traditional software fails, it usually crashes, right? You get a blue screen or it throws an obvious error code.
It's very loud about failing.
Exactly. But when a probabilistic model fails, it often generates a beautifully formatted, highly confident wrong answer, just like our consultant's contract clause.
It looks perfect, but it's totally broken.
Yes. So, if you are using AI to generate marketing poster ideas, a silent failure is harmless. If it comes up with a weird idea, who cares? But if you are using it to autonomously approve bank loans, a silent failure could be catastrophic.
Huge difference. Which leads us directly into the fourth point. Verification. How will a person or another system actually check the result?
This is non-negotiable.
If you can't easily verify the AI's output, you really shouldn't be using it for high-stakes tasks. Wrapping it in a system with source citations, like we discussed earlier, is a perfect example of building in verification.
And finally, value. Does the benefit actually justify the added cost and uncertainty of using a probabilistic model?
Because it's not cheap.
Not at all. Running these large models requires immense compute power and a lot of engineering overhead. You shouldn't deploy a complex AI system just because the technology is trendy, especially if a simple script could do the exact same job for a fraction of the cost.
So that checklist, task, signal, risk, verification, and value, it really demystifies the technology. Capability should be earned, component by component. It shouldn't just be added because a product label sounds impressive.
Exactly. When you peel back all the vendor hype, you are left with powerful statistical engines that just need to be managed with discipline. AI is best used when speed has value, when human review is possible, and when mistakes are reversible.
We've covered a massive amount of ground today. We started with the consultant getting burned by a super confident hallucination.
A painful lesson.
We looked under the hood at how tokens and next word prediction make a model incredibly fluent, but completely unconcerned with factual truth. We separated the raw model from the user-facing application and explored why you absolutely need a robust system with retrieval and hard-coded rules to make it safe.
Yeah, and we also mapped out where these pattern matching engines actually belong. Handling messy perception, predicting probabilities, generating iterative drafts, and coordinating workflows.
As long as the risks are meticulously managed through clear verification.
Always.
I want to leave you with one final thought to chew on before we go. We spend so much time worrying about generative AI replacing human writers, artists, and creators.
It's the number one fear people have.
Right. But if generative models are, at their core, prediction engines that prioritize fluency over facts, then creating content from scratch isn't going to be the most valuable human skill in the future.
No, it really won't be.
As these systems get integrated into literally everything we do, the most highly sought-after, indispensable human skill will be verification. Your true value won't be generating the draft. Your value will be acting as the ultimate, critical oversight node in the system architecture.
The human in the loop.
Exactly.
The human who can stare down a highly confident, beautifully written hallucination and separate reality from the math.
If this episode helped you understand AI more clearly, follow No Hype AI on your podcast platform or subscribe to @Rahul on YouTube for more practical content about Go, cloud-native engineering, and AI-native development. This conversation was produced using Notebook LM's AI-generated hosts and is based on the book The AI Builder's Foundation. You'll find the book and author details in the description.